Okay. Question 3. It says an 8-kilogram ball is moving at a speed of 15 meters per second. 8-kilogram ball, 15 meters per second. And it collides with a stationary ball of the same mass. Same mass, stationary. Afterwards, one of them goes this way at 45 degrees, and the other one goes this way at 50 degrees. Now what I know is that the momentum before the collision must equal the momentum after the collision. So I think about all the momentums I had before the collision. This one here would have 8 times 15, which is 120 units of momentum straight sideways. This one here has none. So afterwards, all the momentum must be going straight sideways, and none of it should be going up or down. Now, the scary part is we have very little information over here. So I'm going to write an expression. This one I'll call it momentum of object A. This one the momentum of object B. I want to find the momentum in the x direction of both of these. I want to find the momentum in the y direction of both of these. Now, since I have no numbers, I'm going to use trigonometry to find an expression for these things. So this one's the opposite in the hypotenuse. So sine of 45 equals momentum in the y direction over total momentum. So momentum in the y direction is PA sine 45. And by that same argument, PX is going to be PA cosine 45. And I'm going to do exactly the same thing to the bottom one. This one's going to have a PX, which is going to be PB this time, cos 50, and PY is going to be related to the momentum of B sine 50. So scary math, but just expressions of momentums in the x and y. Now, based on the information of before and after, I'm going to take a look at making some equations. So, momentum in the x direction before, 120. That has to equal all the x direction momentums after. So my 120 is going to equal PA cos 45 plus PB cosine 50. Now, I look at my y directions before, and there were none. There's none in the y direction. Yep, or I could just say that PA sine 45 has to be equal to PB sine 50. I could have them on the same side and move them over, or just kept them there. Now, this is just a system of equations. I have two equations with two unknowns. I'm going to solve for one of them and substitute into the other. Let's say I'm solving for PA. I'm going to find it PB sine 50 divided by sine 45. Perfect. I'm going to plug it into here and see what happens. So I have 120 equals PB sine 50 over sine 45 times cos 45 plus PB cosine 50. Now, as scary as these chunks may seem, they're just numbers. So let's take that scariness away and make them numbers. Making sure I am in degrees is probably important. I'm going to go sine 50 times cos 45 divided by sine 45. And that will give me the chunk that's in front of here. So 120 equals 0.766 pb. Plus, and my cos 50 is 0.643. I'm going to do what next? I'm going to collect my like terms. So those two I'm going to add together. 1.41 pb. Now to get the pb by itself. I divide 120 by 1.41. $85.18. Well, that's the momentum of this object right here. Now, if I wanted the velocity of that object, I'd have to divide it by 8. So, since P equals mv, I have 85.18, and my mass was 8. To find the velocity of that object, I divide both sides by 8. And what if I wanted to find the velocity of the other object? Well, I have an expression right here for PA. PA is going to be my PB times sine 50 divided by sine 45. Now, I just found out my PA or PB was 85.15 or 18. Sine 50 divided by sine 45. PA should be 5.18 sine 50 divided by sine 45 equals 92.3. And if P equals MV, 92.3 equals 8V. Divide both sides by 8. And I'll have the velocity of my other piece. Now, velocities need a direction. Cool part is, we already know the directions. They were given to us in the question. Yep, 50 degrees south of east. The other one, perfect.